Okay, we're going to take a look at this problem which involves a sinusoidal function. It's a function that will have a sine or a cosine trig curve in it. You'll notice first of all that the numbers in that function are a little bit different than the kinds of numbers that we're used to seeing in our problems. We've got well, the pi over 6, which I don't think we've actually seen as a frequency yet. The 1.5 we're going to identify as a shift in the midline, vertical shift, and the 0.75 is our amplitude. So we're going to use those. But first of all, I want to read through the problem and see if I can use anything in the problem to kind of help make sense of where I'm going with it. So the problem is talking about the depth of the water on the shore of a beach as the tide goes in and out. And not that you would see it standing on the sand, but if you're actually standing in the water and you stand there long enough, as the tide comes in, the water will just rise higher on your body, and as the tide goes out, the water will begin to drop down on your body. So we're measuring the depth of the water, and we're measuring that depth in feet, and we're measuring it as a function of time. Well, that's why we're using t as our variable. It tells us time is in hours. Whatever variable we're using in here, time, that's the one that's going to go on the x-axis. So I'll begin by labeling my x-axis time, and we're actually measuring in hours. We'll put the units down there too. D is what the function name is, and D is representing depth. So on our y-axis we'll write that's depth, and we're measuring that in feet. Okay, I want to consider, before I set up my axes, I always go to the x-axis and think, how can I set that up? Are there instructions that tell me what domain to graph? Not in this case, so I'm going to look at the period for this function. The period is going to be calculated. It's always 2 pi over my frequency. Well, here's my frequency number, that number right in front of the t. So it's 2 pi divided by pi over 6. If you do the keep change flip on that bottom fraction, you'll see the pi's will cancel out. You'll end up with 2 times 6 equals 12. I know my period is 12. So I'm going to graph one full cycle of this thing using the period of 12, which means I'll start at 0. Remember, for time we often choose 0 as our starting point, and let's mark off 12. I'm going to use 24 boxes on here, and you always want to use some multiple of what your period is. So I'll do 2, 4, 6. I think I'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and that's just a matter of counting. Make sure you have enough available boxes before you start. It never hurts to work in pencil, because if you end up using an improper number of boxes, then you can always go back and erase it easily. Okay, so my x-axis is set up. Now notice that the pi dropped out. You don't always have to have a pi. That can happen. It's not a problem. We're measuring in hours, and typically we don't measure hours in terms of pi anyway. Let's take a look at the y-axis. And for the y-axis, if we have a midline shift, we want to consider that first. So let me take a look at this 1.5 here and actually recreate a line, or create a line, a horizontal line at y equals 1.5. Well, I'm not quite sure how high I'm going yet. I want to consider that so I have enough room for everything. If I have a midline at 1.5, I'm going to need to use this number as my amplitude. I'll be going up from 1.5, and I'll be going down from 1.5. So let's make sure we take a close look at the up so that we can accommodate it on our y-axis. I need to go up at least as high as 2.25 here. So let me use 2, 4 blocks to represent a 1, and I'll use 2, 4 blocks to represent a 2, and 2, 4 blocks to represent a 3, and that's kind of an arbitrary choice. Just make sure you're going to fit the graph or fit the curve on the page, on the graph. Okay, I've got my x-axis labeled, I got my y-axis labeled. I'm going to now draw in my midline. My midline is 1.5, so let me grab a line tool here, and I'll start it where 1.5 would be, and I'm going to draw a horizontal line right there. That is my new midline, y equals 1.5. You don't have to write y equals 1.5. It's already included in that equation there. Okay, now I have to start plotting points, but I'm not really going to plot the points in the exact same way I did before. I know that cosine has those 5 important points on them, but we want to be careful when we go to label them. If we have a function maximum, well, that would be where it's the maximum value I'm going to add to the midline, which is going to be a 0.75. A function minimum would be below that. So let me go down here and figure out where the minimum would be. I'm going to subtract 0.75, which would give me a 0.75. So this function should oscillate in between 0.75 and 2.25. So I'm just going to make a reference point for myself. That'll be the 0.75, and the 2.25 will be that way. That'll just kind of help keep me honest as I look across the graph. I'm actually going to just note it on this side as well. And you can do that with a, you can just hold the edge of the paper there or the edge of your calculator there or something to kind of keep track of those lines. You could even put in a light pencil line there to keep track of where you're supposed to be. Okay, so we've got a cosine curve here. Remember that the cosine curve always starts up high. Unless it's been reflected, then it would start down low. If it was a sine curve, it'd be starting on the midline. So we're going to be starting this one up at 0.7, not at 0.75, but up at 2.25. We got to go to the midline and then go up 0.75. We'll put a dot right here. We're going to the other end of the curve. We're going out to 12, the end of the cycle, and we're going to have a dot again up on the 2.25 line. Halfway through the cycle, we're going to have a dot, well, exactly halfway between 0 and 12 is 6, so I'm going to the x-axis at 6, and I'm going to put a dot right there. And now we've got two more important points we want to plot, one on the midline 1/4 of the way and one on the midline 3/4 of the way. And so now I have my curve ready to draw with the pencil. Do your best to show the curvature, especially on the ends. It's kind of hard when it's stretched out like that. And that's nice. I have the curve drawn. That's what my tide looks like over the course of 12 hours. But now I've got some questions to answer. So let's see how I'm going to do this. It says, in how many hours will the tide be at its lowest? Well, you can see from the curve here, the absolute minimum of this curve is going to be after 6 hours. So I want to be sure to label 6 hours and how many hours, and that should make sense to you. How deep will the water be 2 hours after high tide? Well, high tide is obviously here, what we're going to do, and that's a 0 starting point. So we're going to start at 0 and we're going to go 1 hour, 2 hours. So the question is, how high is that curve when I'm at 2 hours? And I can read up and I can go, oh, well, that's how high it is, but I really don't know what that number is. You know, there's a lot of guesswork going on in here. Well, if I gave you an x value of 2, you could plug that in and get a y value. What I'm giving you is I'm giving you a t value of 2, and you could plug it in to find d of t. So that would look like this: 0.75 times cosine of pi over 6 times 2, we'll put that over 1 just for ease of working with the fractions, plus 1.5. And now I could pick up my calculator, and on my calculator I could start typing that in. I'll grab the calculator here and we'll see what this actually works out to be. Go to calculator page. You want to make sure, I'm going to just go check my settings here, make sure I'm in degree mode before I get carried away. I am. So now I can go back to the calculator page and I'll be typing in 0.75 times the cosine. Well, I have a pi over 6 there, and I'm working in degree mode. So before you enter that into the calculator, you want to think about the fact that we put everything in degree mode. How about we turn this pi into 180 so that we're working with what we should be working with. 180 over 6 is equal to 30. I'm going to type 30 for degrees here, times 2. I'm going to get outside. Oh, did I put something in there I shouldn't have? Yep, 30 times 2. I'm going to close the parentheses off, and then I'm going to add 1.5 at the end. And when I hit that, it says 1.875. Well, I just found my y value actually being my depth in this case. So the answer here is 1.875 feet. I'm going to jot that down. I don't have any rounding instructions, so I'll leave it that exact value. And then the question says, when will the water be 2 feet deep? Well, the question about when will the water be 2 feet deep is actually involving my y-axis or my depth axis. So the question is, where will, now that circle that at 2 hours, that circle is not at 2, and a graph can be a little bit deceiving, you can't read it from the graph. That's actually a 1.875, so that how high it goes is actually a little bit under a little bit under 2. So now the question, when will the water be at 2 feet deep? Well, now I'm being given a y value. So I guess if I'm being given a y value, I kind of need to turn that function around, and that's not hard to do as long as you understand what the question is asking you to do. What I have now is I have a d of t. I have a depth. So I'm going to say 2, and we are working with feet, is equal to 0.75 times the cosine of, and again, I'm in degree mode in the calculator, so I think I'll just make that switch again to degrees. So it's going to be 30 times 2 is 60 degrees plus 1.5. And now I'm going to, oh, I made a mistake there. I don't know what this is. I don't know what the x value is, and I'm actually looking for it. So I'm going to erase that 60. I'm going to go back to what I had. It's going to be 30, but I don't know what t is. To call it t, call it x. It's your variable, plus 1.5. Okay, we're going to start shifting things around here until we can solve this. I'll first begin by moving the 1.5 to the other side. Same as we solve any function, we do our moving first before we do our undoing. So now it says 0.5 is equal to 0.75 times the cosine of 30t. I'm going to divide both sides by 0.75 to get rid of that. I'm erasing as I go so I can buy myself a little screen space here. Let's pick back up the calculator. I want to do that not by hand there, so I'm going to type a 0.5 divided by 0.75. Enter that. So as a fraction, that gives me 2/3. So 2/3 is equal to the cosine of 30t. Now remember, t is a time measure. If I know what the value of the value of this angle is, that means I'm looking for the angle in here. So what I need to do is I need to use an inverse cosine. I'm actually going to take the inverse cosine of both sides. If you watch what happens here, inverse cosine of 2/3 and inverse cosine of this expression, on the right hand side, the cosine and the cosine inverse are canceling each other out. Move that out of the way. So now my equation becomes inverse cosine of 2/3 is equal to 30t. We'll pick up our calculator again and ask it to calculate the inverse cosine of 2/3 for us. So we'll go to trig, inverse cosine, 2 divided by 3, and that's going to give us a 48.1896. I'm going to do a little bit of rounding here. We'll call that 48.2 is equal to 30t. And now to finish up, it's pretty simple. We're going to do 48.2 divided by 30, and that'll give us our time measure, 48.2 divided by 30. And it looks like 1.606, so we'll round that off to 1.6 hours. And you didn't have rounding instructions in this problem. T equals 1.6 hours. Didn't have rounding instructions in this problem, but the idea of this problem was to show you how to go about doing this. And let's just check to make sure that makes sense. We said that the water will be below, at 2 hours, the water is going to be below 2 feet. It's going to be 1.875 feet. So at 2 hours, that means it's still a little bit higher, or at 1.6 hours, it should still be a little bit higher. than the 1.875 we found. So yeah, there's a lot of thinking going through that. If you're asked for a y value, you can simply plug in the x value. Even if the variables have changed, that's still what's going on. But if you're asked for the x value, that means you're given the y value, and you're going to need your inverse trig functions in order to solve that problem. So I just want to review with you one more slide what we're actually doing anytime we're using an inverse function. In the last unit, I asked you what the cosine of theta, or asked you to find theta if the cosine of theta was equal to 0.75. In this unit, the functions look a little bit more sophisticated. I'm asking you to tell me if I know the depth. So if I know that I'm at 2 feet, then I'm asking you to solve this equation for the x value, or the time value, and it was equal to 0.75 times cosine of 30. Again, we changed to degrees because that's the motor calculators in t plus 1.5. So I'm really going to do the same thing to both of these equations. I'm taking the cosine inverse of both sides, and I showed you this earlier on in the last unit, but I didn't say I said you didn't have to write it on your paper every time. Cosine inverse and cosine have just canceled each other out, leaves me with theta equals, and I would have picked up my calculator and I would have typed cosine inverse of 0.75. So you were doing that, finding the angle. We're going to have to do the same thing when we get to that step in the problem. We subtracted the 1.5 from both sides. After we did that, we were left with this. We divided both sides by 0.75. After we did that, we were left with a 2/3 over here, equals cosine of 30t. So we were at the point here that we needed to use an inverse cosine function on both sides. When you have that cosine all by itself, like it was here, now it's all by itself. Now this would be the appropriate time to ask for cosine inverse. And this is a number you can get out of your calculator. That'll leave the 30t all by itself. You divide the 30t's out.